It's K8BYP on a fun day Sunday in the Ham Shack, and on the final stretches of the custom designed power supply for the HP 86.6 generator, and I'm going through this with an absolute fine tooth comb to make sure there's no strange unwanted currents running back and forth between power supplies. And the topic of this video is what's referred to as grounding equipment together. Common MAME, common practice. There's a couple problems with it. Let's say there's equipment down here. I have the Yaesu rig connected to the other rigs for keying. It's been practiced to connect them together to eliminate voltage that exists between the two. There are problems with that in that connecting that together then allows for current flow instead of having a voltage difference. That can be a problem to iron that out, but let's assume that this power supply assembly here that goes on the back of the generator is some pile of circuits, and they connect with this arbitrary waveform generator in and out. And I've got the negative of the voltmeter connected to the so-called ground on the AWG. And I'm going to measure potential differences between the two. What we're going to find, and I'll show it to you, is voltage differences and significant differences between the two. And if we then go to connect a signal connector between the two, that can cause serious problems with corruption of the signal. So the common practice is said to be grounding the equipment together, and that is a very bad term, because what controls grounding is National Electric Code in the U.S., and NEC in the U.S. says that ground is always and only the earth, and we are forbidden by code to earth ground anything in this room that's not at the service entrance. NEC 250A4 says we may not reground the load. See that AC outlet? Narrow blades L1, wide blades neutral. What's that? Everybody says, that's ground. Okay, so if you say that's ground, hold up your right hand, say that's ground, and then hit yourself really, really hard upside the head, because that is wrong. That terminal is not ground. It is no more ground, and it is exactly the same as what's connected to the neutral terminal, because ideally they're both the same wire and the same outlet across the same cord, and they run back in the same non-metallic cable to the same breaker box and go to the same terminal. This is not ground. Code forbids grounding anything in the house. The only ground that's allowed to be is on the service entrance at the weatherhead. So we're going to dispense with the idea of ground, and we're going to pick up the correct term, which is commoning. That's not so much used in the US, it's used in England, but it conveys a correct meaning. Commoning these pieces of equipment together to minimize voltage potentials across the two. So I'm going to plug in this assembly here. I see it's already plugged in. This is a disconnected fan and 4 power supplies, plus 5, plus 20, minus 40, and minus 10. And with the handy dandy meter, we're going to measure the voltages across these two pieces of equipment. And the meter is already commoned to this piece of equipment. So I'm going to take the voltmeter and I'm going to touch plus minus, and supposed ground and supposed neutral on each of these power supplies, so you can see in the meter what the results are. there is, on the plus 20 volt supply at the so-called earth terminal, a strange reading. And when a voltmeter is set on DC and we get a weird reading like that, it probably means there's an AC component. But notice there are anywhere from a couple of volts to a couple hundred millivolts. See the millivolt indicator on that supply. And on that supply, and there's its so-called ground terminal, and there's its neutral terminal. Isn't that interesting? All that jumpy voltage went away, and the line terminal L1 reads some strange thing. And notice it's reading the same strange thing as this minus terminal from the DC power supply. That's a warning. Be very careful. The fourth power supply, similar thing. .300 some millivolts. A couple of volts with a really unstable reading. The so-called earth terminal, same. The so-called earth terminal, about the same reading and same kind of reading as touching L1. And this immediately tells us that there's AC floating around here. Now what tipped me off to the fact that there's AC line leakage was touching the metal over here and the metal over there and getting just a little tiny bit, almost imperceptible buzz, a shock. And that's small amounts of AC line current. Now, none of these supplies have the so-called earth terminal connected. And that is the source of the problem, but we need to understand why. We can't just go willy-nilly grounding that and pretending that everything's okay, because it isn't. We put the meter on AC volts and repeat the experiment with 20 volt minus supply. That's the minus DC terminal on the 20 volt power supply. A switching power supply reads 62 volts AC. See the AC voltage? Plus terminal, 62 volts AC. Earth terminal, 60 volts AC. Neutral terminal, 145 millivolts. Why? Why is that suddenly a very low value? Well, because this generator back here has an AC power cord with the neutral line reference to the chassis, and the neutral in these power supplies are also referenced to the same neutral. So there's essentially no voltage drop across the two. We touch the L1 terminal, and there it is, 124 volts AC. So what that means is that there's something odd inside these power supplies, something causing AC leakage. If we go back to especially the old days of power transformers, this was a problem with AC line leakage. The fact that those windings are masses of copper separated by insulation means that they are capacitance in between the two. And that allows AC line current to leak into the secondary of the transformer. Whether it's an isolation transformer or not, it's going to happen. And notice that all these supplies here are referenced to earth. That's the earth ground symbol. That's actually not quite correct. That should be chassis symbol. But back here on the AC line input at the Qualcomm filter, see the ground symbol there, and the center terminal is supposedly ground. Now again, the neutral and the ground terminal go to exactly the same place in the fuse or breaker box. So that is not ground. And the problem that has occurred, that I was able to prove from taking these little switch mode power supplies apart, is that inside they have put disc ceramic safety capacitors from the AC line driven rectified filtered DC input to the switching supply over to that so-called ground terminal, the one here that's not connected. So since that's not connected, that's allowing the leakage current from the AC power supply and some leakage across maybe the switch mode transformer. And there's also a small disc ceramic from this so-called earth terminal to the minus terminal on the power supply unit. So that's why those strange readings appear everywhere. They're all connected together. All four of these except L1 are all connected together inside by disc ceramic capacitors. And L1 is eventually connected to all these through leakage. And so-called commoning, it's not grounding, but commoning this so-called earth terminal allows that current to be drained off effectively. So those voltage drops disappear. That's nice. That makes everything at essentially the same voltage potential, but now it's caused another problem. And that other problem is that the voltage difference went away, but now we've caused a leakage current. It may not be current between this pile of equipment and that generator, but now, since the neutral here and this improperly termed ground terminal are not tied together here, they are tied together 150 feet away in a breaker box. And if there's current from here due to leakage from L1 that's being, as we improperly say, grounded out, now that's causing a current that's going down one leg of that 150 foot of cable and coming back the other 150 feet. We've made a big ground loop. Now, as far as AC line current goes, who really cares? It's not a crisis. The problem is that makes a huge RF pickup. So now there's a big loop antenna between these two terminals, and they're coupled to these. And this is where strange RFI problems come from. So what I'm going to do, I can't have this 60 volt potential between these units and the other line operated device, just like since these switch mode power supplies here have replaced 1, 2, 3 supplies in this Hewlett-Packard unit, but there are 1, 2, 3, 4 other unregulated supplies still operated off the original transformer. I can't connect these two sets of power supplies together unless they're commoned, because that can put all kinds of strange voltages across the circuits out there in this high precision RF generator unit that can cause improper operation or maybe even damage. And way out there in the computer unit here, that operates on 5 volts, which is coming from this switch mode unit. But the LED drivers and indicators for the front of the control computer operate off this 4 volt supply down here from the transformer. So if I don't common those together, there's going to be all kinds of strange voltages across the circuits out there in that control unit. And those are old TTL and possibly CMOS. And we do not want to do that for no price. That old stuff is delicate. So I've avoided so far talking about this in-shack grounding because there is no such thing. Grounding in the shack is forbidden by code. NEC 250A4. I've got plenty of video information here on what's wrong with that. But this gets to the practice of commoning. If we touch two pieces of equipment with our hands and we get a little buzz, that's AC line leakage because the equipments are using different power transformers. So we if we're going to put a signal connection between the two, we can't have that AC line current running across that signal line, because that can cause bad things to happen. So we might have no choice but to either common them together with a jumper wire maybe across the back of the cabinets. That is not grounding. Not grounding. That's commoning, because the wire between those two radios has nothing to do with earth ground whatsoever. And if that allows some unwanted currents to flow across the chassis in some other place, then maybe that's an acceptable trade-off for not having that current flowing across that microphone, key, whatever functional connection between the two. So that's something we do to solve AC line leakage problems that might cause uh, unwanted keying of a radio transmitter. In the old days, or even now with a phonograph, a record player, especially in the old days with tube type stereos and phonographs, there might have been a ground strap between the phonograph and the stereo tuner, because the phonograph input was such an extremely small level, down to a millivolts input, that without commoning the turntable and the stereo together, especially if the turntable had a separate transformer, if they weren't common together, the AC hum would simply wipe out the phonograph signal. So there are times and reasons to common equipment together, but you've got to be extremely careful doing it, because the unintended consequences can be equipment damage or RF interference. So there's the skinny on commoning at the load. It is not grounding at the load. Again, regrounding at the load is not permitted by NEC. So there's, like Paul Harvey used to say, there's the rest of the story. KBYP did it.